In the first lecture we had seen the concept of a force, and we were even talking about finding the resultant force. Today let us go ahead and solve a few problems related to finding the resultant and then proceed with the equilibrium part in the two-dimensional. The problem is given to us is like this. There is a bracket which is fitted to the ceiling, say. Of course, all these details may not be required. And then there are three strings attached to it. 1, 2 and 3. Each of these strings is pulling the bracket. They are exerting the forces which are respectively say T1, T2, T3, and the angles made by them with horizontal are 25 degrees, 70 degrees, and here it is 35 degrees. The magnitudes, this is 100 Newton, this is 115 newtons, whereas T3 is given as 147 newtons. And we are required to find the resultant of these three tensions and determine as in which direction the net force is acting. Now if we follow our usual convention, then the diagram can be reproduced, or you can simply drop perpendiculars over here if you are to solve it by the analytical technique. And then we can determine, when we consider this as positive direction of x-axis and this as positive direction of y-axis, then when we consider sum of horizontal forces, it is going to be T1 cos 25 towards right, so positive, T2 cos 70 towards right, so positive, and T3 cos 35 degrees towards left, so negative. And then after substituting the values, you can find out the answer of sigma fx, so many newtons. Similarly, sigma fy, it will be T1 sin 25 towards left, negative, then T2 sin 70 towards down actually, so negative, and T3 sin 35 degrees, again negative. And then we can find out the resultant, which is under root of sigma fx square plus sigma fy square. And of course angle theta can be found out as tan inverse of sigma fy upon sigma fx with the appropriate signs.